thermal expansion of a liquid. So when the liquid in vessel is heated, both liquid and vessel expand in volume. So however, the liquid in the solid container expand more than the solid, resulting in the rise in the level of liquid. Okay, contoh dia kalau kita kata kita ada satu tank. Okay, you have satu tank. Tank you isi dengan you isi dengan liquid macam gasoline ke kan. And then once we heated the steel ataupun the container, the tank ni, dia akan expand. Tank akan expand dan gasoline dekat dalam dia pun akan expand juga. So kat sini kita boleh tahu gasoline tu akan melimpah keluar ataupun kita panggil overflow. So dekat sini boleh kira lah. Okay, so maksud dia kat sini dia dah bagi tahu lah, liquid in the solid container expand more than the solid. Okay, so resulting in the rise in the level of liquid. So kita boleh consider lah initially untuk volume bagi liquid ni sama dengan volume bagi container. Tu hint dia lah. Okay, so liquid V liquid, V not liquid is times with 1 plus gamma liquid times delta T. Okay, so kita boleh juga kira untuk V solid iaitu container ni, container. So V solid equal to V not solid, iaitu V not solid dengan V not bagi liquid ni sama. Sama sebab liquid ni duduk penuh pada isi padu isi padu solid lah ataupun container ke tank ke. Okay, 1 plus gamma solid times with delta T. Okay, kadang-kadang solid ni dia bagi dalam terms of linear expansion. So alpha, jadi nak dapatkan gamma solid you kena 3 kali dengan alpha solid. Okay, so the rise in a volume ataupun kita panggil amount of split out ataupun overflow. So kita boleh cari change of V lah. Change of V di mana V liquid yang baru kita kira tadi bila dia expand pada certain temperature, so minus dengan V solid pada dia expand pada certain temperature. So you akan dapat lah berapa amount of split ataupun overflow. Okay, so look at some example. So example 1, we have area of metal plate change from 120 meter square to 120.059 meter square when the temperature increased by 30 degrees Celsius. Calculate the coefficient of linear expansion of the metal. Linear expansion is alpha, but the change in area. So relation equation is change in area is equal to beta times with A naught delta T. So as you can see, the equation asks you to determine the coefficient of linear expansion. Kita nak cari alpha. So what relationship between alpha and beta? Beta is equal to 2 alpha. Substitute the value. Okay, so we get alpha is equal to 819 times 10 to the power of negative 6 per Kelvin or per Celsius, per degree Celsius. Either one lah you boleh pilih. Walaupun temperature dia dalam Celsius. Okay saja. Because bila kita dah kira change, ni boleh jadi change in Kelvin, ni boleh jadi change in Celsius. Macam itulah. Okay, number 2, the dimension of an aluminium wire at room temperature is 27 degrees Celsius. Is 150 meter long and cross-sectional area 3 times 10 to the power of negative 6 meter square. It is then melted to form a spherical ball. If the coefficient of linear thermal expansion of the aluminium is 22.2 times 10 to the power of negative 6 per Kelvin, calculate the volume of the spherical ball at room temperature. So first you ada satu bentuk dimension of aluminium. Okay, contoh macam ni lah bentuk dia. And then bila kita meltkan dia bentuk dalam spherical ball, dia punya volume tidak berubah. Okay, volume you boleh kira dia sama dengan cross-sectional area times dengan length. Okay, so we get the value of volume of the spherical ball at room temperature is 4.5 times 10 to the power of negative 4 meter cube. Even though you have change in shape, okay, tapi isi padunya tetap sama. Okay, next is change in the volume of the sphere of it is heated to 200 degrees Celsius. Okay, by using change in V is equal to gamma V naught delta T. So they given the coefficient is for linear. Coefficient of linear thermal expansion. Untuk kira volume thermal ni kita kena kali dengan 3. So 3 times 22.2 times 10 to the power of negative 6 times with V0 times with change in temperature 200 minus 27 because they said final minus initial. Okay, 5.18 times 10 to the power of negative 6 meter cube. Okay, how about C? Change in the volume of sphere of it is cool to negative 7 degrees Celsius. Okay, so you have to change for change in temperature is negative 7 degree minus 27 degree Celsius. Okay, so we get negative 1.019 times 10 to the power of negative 6 meter cube. So this one, this is case expand lah. Yang ni kita panggil case yang shrink. Okay. Next, example 3, we have 70 liter steel gas tank of the car is filled to the top with the gasoline at 20 degrees Celsius. The car sit in the sun and the tank reach a temperature of 40 degrees Celsius. How much gasoline do you expect to overflow from the tank? Okay, first thing first, you kena tahu initial when dia punya temperature in 20 degrees Celsius, the gasoline in the tank, steel tank, macam ni lah, memenuhi lah. Okay, after dia reach 40 degrees Celsius, dia akan tahu dia akan ada berlakunya overflow. Why? Because the steel gas tank and the gasoline itself will be expand. Okay, so initially we know that V0 for gasoline and V0 for tank is equal 70 liter. Okay, kalau dia guna liter, kita boleh je dapat jawapan dalam liter, tak ada masalah. Okay, so kita nak dapatkan berapa banyak tank expand, berapa banyak gasoline expand, kita kena kira by equation yang panjang. Okay, V tank is equal to V0 times with 1 plus gamma delta T. So kat sini kalau you perasan, tank dia adalah steel, dia bagi coefficient of alpha, linear expansion. So kita nak cari gamma, kena darab dengan 3. Okay, kira and then you dapatlah 70.0504 liter. Okay, how about V of gasoline expand pada certain temperature of 40 degree? So, kita akan dapat 71.33 liter. Okay, so VG overflow adalah VG kita dapat 71.33 minus dengan V tank 70.0504 liter. So, we get 1.28 liter. Ni adalah yang spill out lah. Okay. So, next. A hollow aluminium cylinder has an internal capacity of 2000 cm3. So it is completely filled with the turpentine at 20 degrees Celsius. The turpentine and the aluminium cylinder are then slowly warmed together to 80 degrees Celsius. So the case for question number 4 is equal to the case of question number 3. So how much turpentine overflow? So you have to determine how much the aluminium expand and how much the turpentine expand. Okay, so I calculate for volume of aluminium expand is 2008.64 cm3. So kat sini hint dia adalah initially volume for aluminium cylinder is equal to the volume of turpentine. Because turpentine kita fill in dalam aluminium cylinder. Okay, so for volume expand by turpentine is 2108 cm3. Okay, after that, what the change of V? Because how much turpentine overflow? So, expand of the turpentine minus we expand volume of aluminium. So, we get 99.36 cm3. Okay, how about what is the volume of turpentine remaining in the cylinder at 80 degrees Celsius? Dia adalah sama juga dengan volume expand by the aluminium, iaitu 208.64. Ataupun you boleh buatlah turpentine, you dapat turpentine kan 2108 cm3, you tolaklah dengan yang spill out. So yang itulah yang tinggal. Turpentine yang tinggal adalah sebanyak mana expand of the aluminium cylinder. Okay, that's all.